While crossing a beam and NDB, an aircraft undergoes relative bearing change of 10 degrees in 15 minutes with a ground speed of 180 knots. It's a very commonly asked question for the exam. If the mean fuel consumption is 500 kilograms per hour, find the distance, time, and fuel required to the destination. There's a bit of uncertainty in this question as such, but we'll just clarify it soon. Here, you're asked to find out the distance, time, and fuel required to a destination. What is given? You're crossing an NDB. While crossing an NDB, an aircraft, a beam and NDB. What is a beam? A beam means
is
perpendicular.
You are
right?
Yeah, a certain distance, but just east or west.
That's right. So basically, if this aircraft is traveling in that direction, you are the NDB there. Then now I'm not a beam. Now while I exactly cross you, and if I look through my wing, I'll be able to see the NDB. Then that is a beam. It could be traveling in that direction, or I could be traveling in this direction. But that is when you cross the NDB, a beam, any given direction, right? Now while crossing an NDB, a beam, an aircraft undergoes relative bearing change of 10 degrees in 15 minutes. Now imagine. Let's consider a random example here before we look into that particular question. So imagine that I have an NDB here, and my track is like this. This is my track, the track flown by the aircraft. Now at this particular point here, I take the bearing towards the NDB. How will I take the bearing? I'll tune in to the frequency, and the ADF is going to tell me where the NDB is straight. Yeah, and this is where the NDB is. And say for example, what is this relative bearing roughly? So from the nose of the aircraft, this itself is 270. Therefore, this is going to be maybe 300. This is a QDM. QDM is what RBI indicates, RMI indicates. So, but here this relative bearing of 300. So, depending upon what the heading of the aircraft is, you'll have to probably add the heading and you'll get the QDM. So, what I mentioned is a relative bearing. Okay. Now, let the aircraft reach here. Now, say for example, the ground speed of the aircraft is 180 knots, and this is happening at 10 o'clock, and this is happening at 10 hours 6 minutes. At 10 hours 6 minutes at a ground speed of 180, you again take the bearing from the NDB. So if you look at the ADF continuously tuned in, you can see the needless kind of doing this as you reach here, because it is simply locked onto the NDB, right? So we have the ADF pointing towards the NDB like this, and then if I draw it straight, that's how I have. Now, okay, what is the relative bearing? Roughly, it's less than 270, right? So I'll take it as say 225 or something. Relative, right? Let me just bring these relative values. So what is the change in? Let me just bring the relative bearings to a bit of a smaller value. Let me keep this as say for example 275, and let me keep this to 260. Yep, this is more than 270, this is less than 270, right? What is the change in bearing?
10 degrees.
The change in relative bearing you can see here from 275 to 260. So what is the change in bearing?
15 degrees.
Yeah, 15 degrees. So where is the 15 degrees? The change in bearing is right here. That is 15 degrees. We can say this 275, this is 260. Therefore, even though these are relative bearings, the change in relative bearing is going to be 15 degrees. What is the time change?
6 minutes.
Change in time is 6 minutes, right? Now, in such kind of situations, you will be asked to find out what is the range of the aircraft. Now, if I draw a line that is perpendicular, this is the time when the aircraft is abeam the station. Let me draw the aircraft here. So I'll just remove this thing here. And the moment the aircraft is here, now I can say that the aircraft is abeam the NDB. Or NDB is abeam the aircraft, the abeam position. So the aircraft is like this. Or it could be like this as well. In that case, if you look through the wing straight, you can see the NDB. This is when the aircraft is crossing abeam the NDB. What is the bearing here? What is the relative bearing?
Relative bearing is 270.
You can see the relative bearing is 270. Nose of the aircraft all the way till here. 270 is the relative bearing, right? So if we have the NDB here and the aircraft crossing in that direction, the relative bearing is 270. Or if the aircraft NDB is here and the aircraft is crossing in this direction. Now when the NDB is abeam the aircraft, what is the relative bearing from the nose clockwise? It's 90. Right? So when you're abeam, the relative bearings are either 270 or 90, depending upon what direction you're traveling. No other bearings. Alright. Now the common question that they ask is to find out the range R. So by range, what they mean is the distance at the point of the closest approach. So at what point is the aircraft reaching the closest to the NDB? It's when it is abeam. And now it's moving further. You can see its range here. This is the smallest, therefore the closest, right? But this is basically the point of closest approach, and you have to find out this R. How will you find out this?
If it's abeam means that is 90 degree and that particular angle I can split.
This is 90, right? This is 90, right? So what is this? What is this angle? From bearing of 275 to a bearing of 270, it's 5 degrees.
5 degrees.
270 to 260,
10 degrees.
10 degrees. All right. Now, if you look at this triangle here, and if we apply 1 in 60, you can find out this distance R here. Now, can I apply 1 in 60? Yes, I can, because the angle is less than 20. So I can apply 1 in 60 here, right? So if I apply 1 in 60, tracker is equal to distance of by distance gone to 60. What is the tracker? 5 degrees. What is the distance of? You have to treat this as the distance of this one. The side opposite to the angle is the distance of. So that is how much? This is 100. This is 106. You probably have to have the time that you would take to all the way reach here. So what is the distance gone? That is more like your range here. This is the range. So this is the distance here. This is the distance of. By distance gone is R. So if you have this distance off, then you can very well find out what the range is. This is what is this range is a point of.
I'm just thinking, why is this the distance off and that it should be the other way?
To take the normal triangle, the tracker is this. The side opposite to the tracker is the distance off. So this is the tracker, the angle here. So side opposite to that is the distance off. Right? And then this is more like distance gone or distance to go, which is a range R. So if you have these parameters, one of them given in the question, then you can probably find the other one. Right? So look at this question here. In this particular question, you can just write this as an example, just a rough figure, the bearing change, the time change. So similarly, you can apply 1 in 60 here as well, and then you can see the distance. The tracker is 10 degrees here. Distance off is so much. My distance gone is again the range. Look at this triangle here. If this angle is small, what is the angle here? Total angle is how much? 5 plus 10, which is 15 is a smaller angle. By smaller we mean you're trying to apply 1 in 60. So by smaller we mean less than 20 is what is like smaller angle. If it is smaller, the idea is I can take this distance is equal to this distance is equal to this distance. It's all relatively same. So if I take a compass here, if I draw an arc all the way straight, it's more or less going to be same for smaller angles, not for larger angles, right? So if you take a larger angle, say for example, an angle like 10 degrees here, you can take these two sides almost same. But if you take a larger angle like 45 degrees, you can see that there is no way you can take these two sides the same. It's not going to be same. So it kind of disintegrates about 20 degrees. right? So all right, so how will I find the range here? So having this understanding that if this is R, all this is going to be R. We can assume in that way. So what I'm going to do is I'm going to add these two. Instead of considering them as separate triangles, I can think this is combined. A triangle with angle is 5 degrees, and this is the range which is asked in the question. This is the point of closest approach, but I can take all this as R, and if I take this triangle as a whole, this time is 10, this is 10.6 at a ground speed of 180 knots. If I apply 1 and 60 to the entire triangle, track error is equal to distance of, by distance gone to 60. What's the track error? The combined track error is 15 degrees. What's the distance of? The side that is opposite to the angular distance of. Will you be able to find this distance? You have 6 minutes of travel over 180 nautical miles. So find out what's the distance?
Nautical miles per.
Yeah. How many?
So that 3 nautical miles.
Yeah. That's right. 3 nautical miles per minute. Therefore, it's 18 nautical miles. Right? So it's 18 nautical miles divided by what is distance gone? Distance gone is the other side which you want to find out. The range into 60. What's the range? 18 divided by 15 into 60. Right? So it becomes
72.
70 nautical mile is the distance. So usually in the question they'll ask you what is the distance to a station. So distance to a station can be depending upon where the aircraft is. Distance to station is different. But for smaller angles, we assume that it is relatively same. All these distances are same. So that is going to be 72 nautical miles is the range. Right? Now, how long will it take for the aircraft to track to station? If it wants to track to a station for somehow like this, how long will it take? This range is 72 nautical miles. Ground speed is 180 knots. So you can find the time taken to reach the station. Distance
24 minutes.
by speed 24 minutes. Right? Now if your, say for example, if your aircraft has a fuel consumption of say 600 kilograms per hour, how long will it take for the aircraft? What's the fuel consumption in reaching the destination? 600 kilograms per hour, it takes 24
240.
minutes. Yeah? So how do you calculate fuel required? Is equal to 24 minutes is 24 divided by 60 hours into 600, 240 kilograms.